Welcome to the most important video of your life. If you watch till the end of this video, you will become a safer driver and a safer pedestrian. Watch as we explain the physics behind car safety.
First, let's talk about how badly this guy is hurt.
Let's talk about the conservation of momentum during the crash. The person's momentum and the car's momentum before the crash is going to be the same as the momentum after the crash. The person's velocity is 0 and therefore has no momentum, but I both sides by the combined mass to derive an expression for final velocity. The mass of the car over this combined mass is going to be roughly 1. So therefore, the final velocity is going to be roughly the car's velocity. Using real-world values, we can derive an expression for the acceleration the person experienced during the crash, 78.25 meters per second squared. Using Newton's second law, we can then derive an expression for the force the person experienced, 4,700 newtons, which is enough to break your femurs.
Now let's see how ice affects the road.
The car is being acted upon by 4 different forces. Forces are gravity, the normal force, the applied force of the engine, and friction as the car moves. The force of friction is going to be equivalent to this coefficient of static friction times the normal force, which is the coefficient of friction times the car's mass times gravity. When the road is icy, the coefficient of static friction is going to be roughly 0, and therefore the force of friction is going to be roughly 0. Therefore, the car cannot stop and is out of control.
Keep this in mind and you'll be much safer on the roads.